Hello and welcome to Career Making Classes. So, in this session, we are going to learn about carbon and its compounds. So, in this class, this is the part 2 of carbon and its compounds. And in the first part, we have discussed about types of bonds and some interesting facts about carbons and its compounds. So, this is the part 2 of the respective chapter. So, let's get started. So, firstly, we have to discuss about versatile nature of carbon. Actually, carbon is so versatile. Yes, carbon is so versatile. So, why it is versatile? Because of two reasons. Actually, what are the reasons? It has tetravalency, means its valency is 4. Tetra means 4. Yes, it has tetravalency. And the second one is it performs catenation. So, what is tetravalency and what is catenation? Let us discuss these topics. So what is carbon has 4 valency? Yes, carbon has 4 valency. So 4 valency, 4 means tetra, right? So carbon has 4 valency. So what is special about carbon's 4 valency? Like if it has 4 valency, then it can make bonds with many other atoms, right? If it is monovalent, bivalent, trivalent, so it can form with a large number of atoms. So that's what we call versatile nature of carbon, right? So hence carbon follows octet rule. So what is octet rule? Like it has 4 electrons in its last subshell, right? So it contains it required 4 electrons, right, to fulfill its subshell. So octet rule means last orbit should contain 8 electrons. Yes, octet rule means last orbit should contain 8 electrons. So it has 4 electrons. So what it need? 4 electrons. So it maintains sharing. Sharing means covalent bond, and it has 4 electrons. So tetravalency is the term suggested, right? And why it is following octet rule? To maintain its electronic stability. To maintain its electronic stability. Okay, so catenation. Catenation, what is catenation? It is a property by which carbon atom can bond with any number of carbon atoms to form straight chains, branch chains, and rings of various chains. Okay, let us discuss completely about this. Okay, so what is catenation? Actually, catenation is like bonding of carbon, right? Catenation is bonding of carbon, right? Bonding of carbon with other carbons, with other carbon atoms, that we call catenation. See for catenation, C for carbon, means carbon is binding with carbon. This property is called catenation. So this is a special property, right? And why this is so special? Because everyone can bind with themselves, like O2 H2 means 2 hydrogen are binding, 2 oxygens are binding. So what is the special thing about that? Special thing is like it can bind with other carbon atoms in any number. There is no limit. So this is what we call special thing about carbon, and this is what we call catenation. Okay, so our next topic is types of carbon compounds. Like how many types of carbon compounds are there in total? So there are 2 types of carbon compounds. First is saturated and another one is unsaturated. So have you discussed these terms earlier? Yes, we have discussed these terms in our 6th 7th classes, but there's not that relation with that. Saturated, they are solutions, right? But here they are compounds. Like saturated compounds are like they have single bonds. Yes, they have single bonds in their atoms, right? In their compounds they have single bonds, right? In unsaturated means they have double or they have triple bonds. Yes, so this is what we call saturated and unsaturated. Let us see what we have written. Like compounds which are linked by only single bonds between carbon atoms, means carbon atoms having single bond is called saturated carbon atoms, right? And unsaturated carbon atoms, sorry, let us discuss examples as well. Propane, ethane, etc. So these are 2 examples of saturated compounds. Yes, so another is our unsaturated, right? Compounds which are linked by double or triple bonds between the carbon atoms, as we have discussed, right? So we have double bonds and triple bonds between the carbon atoms. So this is called unsaturated carbon atoms. So what are the examples? Examples are propane, ethene, etc. Have you heard these terms earlier? No, you don't. So don't get panic. We are going to discuss these terms in this session only, right? So nothing to worry about these names: propane, ethane, propine, ethene. They are so simple, and we are going to discuss these terms in this session. Okay, in our further slides. Okay, so we have discussed the two types of compounds, saturated, unsaturated, right? So first discuss the formula and structure of saturated compounds. So let us recall what is saturated compounds. Compounds having single bonds, right? Compounds having single bonds are called saturated compounds. So this is the whole table. It is also given in NCERT. You can prefer that, right? So this is the formula and structure of saturated compounds. So we are not going to skip this. We have to learn this table. Actually, we have to understand this table deeply, right? So first is methane, ethane, propane, butane, pentane, hexane. No idea, right? So for learning this table or understanding this table, we have to crack one thing, which is memorization. We have to memorize some terms, right? Half of the chemistry is all about memorization, I must say. Okay, so methane, ethane, propane, butane, pentane, hexane. Meth, M-E-T-H, M-Y-T-H, no M-Y-T-H, it's M-E-T-H, methane. Methane means one, myth means one, okay? That, not that myth, it's myth, not meth. That myth is different thing, right? That's rumors. Myth is rumors, but this myth means one. Okay, what one? We are going to discuss that, don't worry. The second is ethane. It means two, right? Propane, prop means three. And pentane, butane means but means four. It's not but. No, it's not but, it's but. Okay, so but means four. And pent means five. And hex, as we have already discussed these terms in maths as well, right? Hexagon, pentagon, hexagon, right? So hex is 6 and pent is 5. Yes, so here we have these terms and which we are talking about. These terms explain us the counting. Which, for what? For what counting? These terms explain us about the number of carbons, right? Methane, myth means one carbon. Like we have discussed, myth means one what? Carbon. Just like methane means one carbon, ethane means two carbon, propane means 3 carbon, butane means 4 carbon, pentane means 5 carbon, and hexane means 6 carbon. What are the carbon? They are carbon chains. And one more additional point, like we haven't discussed the 3 last terms, right? Ane, methane, ethane. We have discussed, right? What is meth, eth, prop, right? Then what is ane at the end of the word? What does this signifies, right? This ane, what it signifies is, ane means single bond, right? And do you know any another term given to single bond compounds? It is saturated compounds. Yes, if you have saturated compounds, then put ane at the last. Yes, is it? Yes, it is. Okay, so methane, the formula of methane means, how does we have to memorize the formulas as well? No, there's nothing to memorize. It's so easy. How? Okay, carbon, how many bonds can carbon make? Tetravalency means 4 bonds, right? Then we are discussing hydrocarbons. Hydrocarbons means hydrogen, and carbons, right? The bonds between hydrogen and carbons. So we are discussing that especially. So hydrocarbons means carbon is attaching with hydrogen only, right? So methane means 1 carbon. Then how many hydrogen it can bind? 4 hydrogen. So formula will be CH4. Okay. Then another is ethane. Ethane means 2 carbon, right? So here we have the structure, right? So 1 carbon, they are both attaching. So we can't write 8 because the one bond is connected to carbon. So 2 hydrogen will be removed. So there will be C2H6, right? C2H6. Then what about propane? What about propane? Okay, so propane means 3 carbon. So carbon C3 and how many H? Count and say it's 8, right? C3H8. Okay, then what about butane? Butane means C4H10. Yeah, so simple. If you practice these formulas, it will be so simple and it will be interesting for you. Because some people say science is all about memorizing. No, it's so interesting. It's like maths. If you have interest in maths, then it will be so interesting for you. If you don't have interest in maths, still it will be interesting for you if you understand the concepts, because there is no big mathematical calculations here in this chemistry topic, right? So it's so easy, right? So pentane, C5, and we are connecting 5 carbons with together, and the rest of the bonds are connected with hydrogen. So the formula is C6H14. Easy, so easy. Okay, so this we have discussed far away. Okay, so these are the formula and structure of saturated compounds. I know this is going to be a little bit difficult, but trust me, if you don't understand the concepts, rewind my video and understand thoroughly, right? It will be so interesting for you. It will be so interesting. Okay, so let's come to another topic, which is formula and structure of saturated compounds. No, we have discussed saturated compounds. It is error. No, we have to discuss one more thing, right? So far away, we have discussed that compounds are attached with, like, in the branch form, right? Where we have discussed in the catenation topic, right? So it can be attached with branch and it can form rings, various rings. So we haven't discussed about rings. What rings? Right, they have like hula hoops. No, they will form a ring. How? Let's see. I have given one example of that. This is ring. Carbon is forming ring, right? And what about, you said you are so false. You said that carbon will form a ring, right? It is so untrue, right? Carbon is forming a ring, but one thing you have said wrong, totally wrong. What is that? That you said that carbon is attached with 4, right? And here one carbon is attached with only 2. Then what about the rest 2 bonds? What about that? Okay, so don't worry. Actually, this is the way of representation. The carbon has 4 bonds only. The 2 are connected with carbon and the rest are, it's obvious that rest are connected with hydrogen. Okay, so it's obvious thing that rest of the bonds are connected with hydrogen. So it is the way of representation. Okay, so what is this? This is the structure of cyclohexane. What is cyclohexane? We have no far away about hexane. What is cyclohexane? Cyclo means cyclic formation and a hexane, right? It is a ring of hexane, right? It is the ring of hexane. Then what is the formula? I'm not providing you formula. You have to tell me what is the formula. Like C6, right? What is the C6 and what about hydrogens? What about hydrogens, right? It's gonna be 14. C6H14. Okay, yes. So we have discussed about saturated compounds, right? What is unsaturated? What about unsaturated? Yes, we are going to discuss. But tell me, what are unsaturated compounds? Unsaturated compounds they are binding with double bond and triple bond. So this is what we call unsaturated compounds, right? Double bonds and triple bonds, right? So we know we will put a double bonds. In the previous lecture we have discussed about single bonds and double bonds, how to mention that. If you haven't watched that video, then please go back to that video. That video contained very important topics like electron dot structure, types of bonding, and single bond, double bond, etc. Right? So inside unsaturated compound, it is simple to represent by double bonds and single bonds. So we don't have to discuss that. But now we are discussing some special case. Right? What is the special case? This is the special case, presenting you in a special manner. So this is the special case. And why it is special? Because can you see the pattern? C double bond, C single bond, C double bond, C single bond. It's a hexane. Of course it's a hexane, right? But what is the special in it? The pattern, right? The pattern is so obvious. Not obvious, right? Pattern is so crazy, mind-blowing, right? So is there any special name for this special pattern? Or we can say cyclohexane or ene for double bonds, right? Ene for single bonds and ene for double bonds. So cyclohexane. No, there's something special name about that. So what is it? Let's see. It is structure of benzene. The name is benzene, right? Benzene is the special name of this beautiful pattern. C double bond, C single bond, C double bond, C single bond, etc. Okay, so what is the formula of this? Special structure contains special formula. C6H6. So simple and so unique. You know, this is the favorite topic of examiners. Yes, this is the favorite topics of examiner. Why? Because this is unique and examiners are also unique. They will make a unique paper, right? So this is the favorite topic of examiners, and please mark it down here. Okay. So let us come to the another topic, which is homologous series. Before going to that, let us discuss what we have studied far away. We have studied about the versatile nature of carbon, which is two. What we have discussed there, we have discussed two types of compounds, carbon compounds, which are saturated, unsaturated, and we have discussed about formula and structure of saturated and unsaturated compounds. Okay. So let us come to this topic, which is homologous series. Homologous series. Okay. So, what is homologous series? A series of compounds in which same functional group substitutes for hydrogen in a carbon chain is called homologous series. So, before discussing that, we have to discuss one more topic, which is called functional group. What does functional group stated here? Like, we have discussed that carbon is how carbon is attached to hydrogen. But what if there is another thing which is attached in place of hydrogen, which substitutes hydrogen? This can happen. Yes, this can happen. Because why? Because carbon has tetravalency and it can bind with any atom, which is monovalent, bivalent, trivalent. Yes. So what if another atom attaches? Is there any special name of that atom? Yes, this is called functional group. If another atom is attached to the carbon and substitutes hydrogen, it's called a functional group, right? And that is what we call functional group, right? And if same functional groups, like a compound, we have two compounds, they are having same functional group, then they are called homologous series. We don't have to discuss about how many carbons they both contains, but the fact is that they are having same functional group. Let us take an example. Okay, so we have discussed about homologous series. So let us discuss one example, which is CH3OH, C2H5OH, C3H7OH. What are these? Actually, these are homologous compounds. How homologous, right? There is no similarity. One compound contains one carbon and 3 hydrogen. Second contain 2 carbon, 5 hydrogen. Another one contain 3 carbon and 7 hydrogen. Then what is the similarity? You have missed out one thing, which is OH. OH, what is the OH? I have no far away about H, that carbon is attached with H. Then what is the OH? If that H is same like other H, then why it haven't added like CH4? And it will become methane, right? CH4O. But why it is written as CH3OH? Because OH is usually contains alcohols. OH formula is for alcohols, and alcohol is a functional group as it substitutes individual hydrogen, and in place of that hydrogen it put OH. Right? What is OH? It is a functional group, right? So functional group is same here. So we don't have to we don't have to care about, right? We don't have to care about how many carbons are there, how many hydrogens are there. We only just know about functional group. Like how many functional groups are attaching to to a series of compounds, right? Not how many, which functional group is attached to the series of compounds. So there is many compounds which contain that functional group, and this is called homologous compounds. Same we have same functional group, right? Same functional group. So this is what about homologous series, and I hope you have completely known about functional groups. Okay. So another topic we have is nomenclature of carbon compounds. What is nomenclature of carbon compounds? Right? We have already performed this property. Like we have named the carbon compounds as methane, ethane, propane, butane, pentane, hexane. Right? We have already discussed about these. So what is these? These are nomenclature. Nomenclature means giving names. So nomenclature is giving names to carbon compounds, right? Giving names to carbon compounds. So what are these? So there are some basic rules to give names to carbon compounds. So what are they? Let us see. Rule number 1. Find the longest chain to determine parent name, root word. Longest chain. We have discussed about structure, right? We have discussed about carbon is attaching to carbon, 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 right? Is there any chance if carbon is attaching in the single line? No, it can form like one carbon, it is attaching with one carbon this side and one carbon this side and one carbon this side. This could happen as well, right? So we have to consider the longest chain as parent chain. What is the parent chain? We have to name the root word. Which is the root word? Like meth, eth, prop, pent, sorry, but, pent, hexane, hex, right? These are the root words. And how we can consider which root word is to which root word we have to put? By considering the longest chain of carbons, and the longest chain of carbons is called parent chain. Okay, what it is called? Parent chain, right? So I know you are clear with the rule 1. Rule 2 is start counting the carbon atoms closest and of the functional group. Yes, if functional group is present, then start counting the carbon atoms from the functional group, right? It should contain that main parent chain should contain functional group, and if you are numbering the carbons, then the smallest number should be given to the functional group. Then smallest number should be given to the functional group, and the condition is that the functional group should be that functional group attached to the carbon should present in the parent chain. Okay, so easy, right? Let's come to the third rule. Third rule, which says is rule 3. In case of alkenes and alkanes, start counting close to the carbon having double and triple bonds. Right? In case of alkenes and alkenes, okay. So if we have unsaturated compound, what are alkenes? Alkanes, ines, right? We are putting at the last. Okay, so there is an error. There is no alkenes and alkanes, no alkanes, it's alkynes. Okay, so there is an error, so put that. Okay, so I will make sure next time there is no error in my slides, so sorry for that. So alkenes and alkynes. So alkenes is what? Alkenes is carbons having double bonds, and alkynes means carbon having triple bonds, right? So double bonds and triple bond. If a parent chain contains double bond and triple bonds, so how we can put numbering? If there is no functional group, then prioritize your unsaturation point. What is unsaturation point? The point where double bonds and triple bonds are present. Okay, the point where your double bonds and triple bonds are present are called unsaturation points. So identify unsaturation points and start counting from there if functional group is not present. Otherwise, prioritize your functional group. So another rule is if suffix starts with vowels, then remove e. Okay, what is suffix? Suffix means the extra word which is attached back of the right side of the root word, like propane. Yes, prop is the root word and ane is the suffix, right? It is written at the last of the root word, right? Ane. Okay, so e, so remove that e. Okay, why e? Means because e is the one of the vowels, so it's a rule, right? If your suffix root word suffix contains any vowel, then remove that vowel and just put another suffix to it and name it. Okay, propanoic acid, right? Propanoic acid. What is oic acid here? Okay, this is the functional group, and in another lecture, in another part of this video, we are going to learn about what are the basic functional groups we use and how this oic acid word came. We are going to discuss that in another class. So this is the table, right? This is the table of functional groups, right? So haloalkene, first is haloalkene. Halo means not this. Haloalkenes means halogens, right? And alkanes containing halogens. What are the halogens? Like fluorine, chlorine, bromine, iodine, right? Okay, so this is halogens, and if halogens is contained in the carbon compound, then you know how to prioritize, because this is a functional group chain, right? So how to prioritize? First number, the carbon with functional group. The carbon with functional group is given one number, so it could be 1, 2, 3 in the first point. Okay, 1, 2, 3, and there is chlorine, right? Cl means chlorine, and if chlorine is contains is contained in a carbon compound, then put a prefix chloro, right? Chloropropene. Okay, chloropropene. Why ane? Because it contains, why ane? Okay, tell me why ane? Because it has single bonds in it, right? So chloropropene. Chloro means chlorine and propene means, prop means 3 carbons, and ane means all are attached with single bonds. Okay, let us see another example which is written here is bromopropene. Why bromo? Because it is contained bromine. If what if iodine is contains, it would be like iodo, like iodopropene, iodobutene, iodopentene, right? If what if it contains fluorine, it's called fluoropropene, fluoromethane, fluoropentane. Okay, so this is what about haloalkenes. Halo means halogen and alkenes means the carbon compounds contain single bonds. Okay, the carbon compounds contains single bond. Second one is alcohol. Yes, we have discussed about alcohols earlier, right? OH. Yes, this is what we call alcohol. If alcohol is contained in a carbon compound, then put a suffix. Suffix means at the last of the root word, right? The suffix ol is connected, right? Suffix ol is joined, like propanol. Okay, you have to learn these things, right? It's easy, but you have to learn. Okay. Propanol. Propane, yes, there is something wrong here, like propane. E, where is E? As we have discussed in our fourth rule, right, that if suffix contains not that suffix, all is not that suffix. We have discussed the root words suffix, right? Root word suffix. If root word suffix contains vowels, then vowels is cancelled and then another suffix is attached to that, like propane, then cancel out the E and attach ol, propanol. Okay, propanol. Okay, so this is all about alcohols. Another one is aldehyde. What is aldehyde? Aldehyde means carbon is attached to oxygen with double bonds. Yes, this is unsaturated, right? Unsaturated functional group, right? Carbon is attached to other carbons with single bonds only, right? But it is attached to oxygen with double bonds. Yes, this is what we have special in it, right? So what does this, and what is the suffix added to it? The suffix is al, al. We will pronounce it as not al, it's al, right? Propanol, propanal, no, propanol, right? Pentanol, butanol, okay, methanol. Okay, so it is aldehyde, means carbon is attached to double bond oxygen. Okay, so another one is ketone. Ketone means carbon is attached to double bond oxygen. So what is the difference here? Did I write something wrong? No, I didn't write something wrong. Actually, what in case is propanol. Okay, so ketone. Yes, sorry, not propanol, ketone. Actually, ketone. Like ketone, there is some minor difference, right, in aldehyde and ketone. In aldehyde, the carbon attached to the oxygen is not attached to another carbon from both sides. Like the carbon attached to the oxygen, right? Mark my words. The carbon attached to the oxygen is surrounded by carbon chain from one side only, right? And one side is hydrogen. So this is what we call aldehyde. And if carbon is attached to oxygen and surrounded by other carbons from both the sides, it's called ketone. Yes, it is ketone, right? So ketone suffix, and what is the suffix? On, O-N-E, not one. It's not one, it's on, right? It's English. Yeah, it's English. It always be a word which is silent, which is of no use, right? On, ketone, O-N-E, right? Propanone, big word, but meaning easy, right? Ketone means carbon which is attached to double bond oxygen is surrounded by two carbons, two or more than two carbons. Simple as that. Okay, so this is ketone, and the suffix used here is on, right? And the root word is, if root word is propane, then the word is propanone. Okay, propanone. Yes. Fifth functional group is carboxylic acid. Do you remember in the previous slide we have discussed about oic acid? So what is oic acid? This is the time to understand this oic acid. It is carboxylic acid, and the suffix used for carboxylic acid is oic acid. So propanoic acid. Okay, clear? Let's come to the another. No, wait. We haven't discussed about what is oic acid. Okay, we know about word. Then what is the term used in the structure? What is the words used in the structure? Right? This is OH plus double bond O. This is the mixture of what? This is the mixture of aldehyde and alcohols. So that's why carboxylic acid means carbon, double bond, oxygen, and this carbon is surrounded by one side of carbon chain, right? So this is aldehyde, right? And this carbon is not attached with only hydrogen. This carbon is attached with OH, which is alcohol. So this is called carboxylic acid. So what is carboxylic acid? Oic acid. The suffix uses oic acid, and how we can pronounce it as propanoic acid, pentanoic acid, hexanoic acid. So simple, so easy, right? Okay, another term or another functional group, we say alkenes, okay, and alkynes, right? Alkynes, the term is called propyne. Okay, propyne, yes. So this is what about functional groups. So that's it for this video. Stay tuned, be happy, and if you have any doubt and queries, you can write in comment section. I will try my maximum to answer these questions. And at last, I want to say that this was the part 2 of this chapter, carbon and its compounds. And if you haven't watched the part 1, then check out the description. We have provided the link of the chapter 1. So that's it for this video. Thanks for watching.